Yes, we want to work through this example as our starting point for today's lesson. And we are looking at how we are applying the factor formula. We are looking at our application of the factor formula. So we have that the cosine of A I already told you that that requires you to prove and work towards so we shall prove the left hand side, and by the end of our proof we should be able, so this will give us 2 the cosine of A plus B over 2 into the cos of A minus B over 2. We keep this here as equation 1. But these angles are angles of a triangle, meaning that their total angle sum is 180 degrees. So we can go ahead to look for what A plus B is. A plus B here would become 180 minus C. And that means that A plus B over 2 will be the same as 90 minus C over 2. And that implies that if I take the cos of A plus B over 2, I should be able to take the equivalent of what they are saying A plus B is equal to, which is 90 minus C over 2. And when we expand this, the cos of 90 is 0. And when we are expanding a cosine that is being subtracted, of triangles that are being subtracted, we normally have cos, cos, plus sine, sine. So when we expand this, it will simplify to simply sine C over 2. That implies that if we come back here, we already know that cos into A plus B is sine C over 2. Seeing that we already have the sine C over 2, on the right hand side where we intend, whose proof we intend to get right here, we already have that. We can now look at the other part. We look at the other remaining part of the left hand side. The second part of our left hand side that we left there was the cosine of C minus 1. What is it equal to is what we want. Using the double angle, using C as a double angle, if we consider C as a double angle, and take the cos of C, the cos of C as a double angle has 2 expressions. One can be considered as 2, the cos squared C out of 2 minus 1, but it can also be considered as 1 minus 2, the sine squared of C over 2. And it can also be considered as the difference of cos squared C over 2 minus sine squared C over 2. So we shall consider this, that cos of C over 2, cos of C minus 1 cos of c is equal to 1 minus 2 sine squared c over 2. But we have this giving us that if we subtracted 1 from there, this 1 minus this taken this side, will give us minus 2 sine squared c over 2. So we already have two parts now. We have two parts that we can fit in our original expression here. So substituting, I'll take this also as another part, maybe part 3, this being part 2. Substituting in the left hand side, we have cos of a plus b, cos of a plus cos of b plus cos of c minus 1 will give us now cos of a plus cos of b. We have already got it as 2 the sine of c over 2 times the cos of a minus b over 2 plus cos c minus 1 has been obtained just here as minus 2 sine squared c over 2. At this stage, we can factorize our common factor, which is 2, the sine of c over 2. If we factorize it, we shall stay with the cos of a minus b over 2 minus the sine of c over 2. Now our task is to look for c over 2. So we can still say, but from, again, a plus b plus c is equal to 180, our c is 180 minus into a plus b, and our c over 2 will definitely be 90 minus a plus b over 2. So our sine c over 2 is going to be the same as cos of a plus b over 2. So we can substitute for sine c here. We substitute for sine c over 2 in star. Star is this equation. So we'll get 2, the sine c over 2, into cos of a minus b over 2 minus cos of a plus b over 2. The bracketed term also requires us to apply the factor formula again. As I turn the page, we are aware that now we have our expression equivalent to 2, the sine of c over 2, into the cos of a minus b over 2 minus, we just obtained the cos, minus the cos of a plus b over 2. We are all aware, though I don't want to take it for granted, that we all still remember that actually when we are subtracting cos, we get sine, negative sign. So we have our expression as that one, and we want to find out what it is equal to. Now, so what happens? what happens is we are going to get our 2, the sine of c over 2, into, this will be minus 2, the sine of, we first add a minus b plus a plus b. These are all over 2 over 2. So we can put it over 4. And then the sine of a minus b minus a minus b over 4. Over 2 becomes over 4. This will give us 2, the sine of c over 2 into minus 2. This b will cancel out and will give us sine a over 2 finally, because it will be 2a over 4. And this will be sine, the a will cancel out and we get minus b over 2 also. But sine of minus theta is written as minus sine theta. So if we apply that, this minus will come out and join that one. And this will give us 2, the sine of c over 2 times minus 2 times the sine of a over 2 times minus the sine of b over 2. This and that will merge to give us a positive, and our answer will become 2 times 2, which will be a 4, the sine of a over 2, the sine of b over 2, and the sine of c over 2 as required, because this is now equal to the right hand side. So at that stage, we will have proved our expression as required. We can look at the second example now, directly going into the exercise. Between 1, 2, 3, 4, I will prove one of them, and I am going to choose to prove 3. This is 17H, number 3. 17H number 3, they are telling you to prove that the sine of b plus the sine of c over the cos of b plus the cos of c is equal to the tan of b plus c over 2. The left-hand side is what we intend to prove, and these numbers are very, very brief. These proofs are very, very brief. That if we apply the factor formula, sine plus sine is 2 sine cos. So I get 2 sine of b plus c over 2, cos of b minus c over 2, over cos plus cos is 2 cos cos, 2 the cos of b plus c over 2, the cos of b minus c over 2. If you look at that, this cancels, and since we already know that sine of a, for example, over cos of a is tan of a, it implies that the left-hand side from above here will give the 2 will cancel, so will give us the tan of b plus c over 2, which is equal to the right-hand side, hence proved. Hence proved. We can try out one more number, for example, number 17. Number 17 is a question that requires you to solve. Solve for x in the range of 0 to 360 degrees. And they give us a number like the sine of 2x plus the sine of 3x is equal to 0. They want us to solve. Sine plus sine is 2 sine cos, so we shall get this as 2. The sine of 2x plus 3x over 2, the cos of 3x minus 2x over 2 is equal to 0. If we are using factor formula, we have 2 sine of now 5x over 2. The cos of x over 2 is equal to 0. This is an AB situation. A dot B is equal to 0. So if we apply the 0 rule, we should be able to proceed and solve this. I'll move to another page. That our 2, the sine of 5x over 2 is equal to 0, or our cos of x over 2 is equal to 0. Starting with this, we can say that x over 2 is the arc cos of 0. We pull out our calculators and we look for those very angles whose cosine give us 0. The first angle whose second inverse of course is 0 is 90, and the next angle is 270. The next angle is 270. Given the range they are giving us, and given that from here our x will be 2 times 90, because we are cross multiplying their half, and 2 times 270, it implies that x is going to be 180 degrees, and then 540 degrees for now. Then for the case of 5x over 2 equaling to the arc sine of 0, the values of x responsible here, we shall look for quite a number. The first one is 0, the next one is 180, and the next one is 360. If we are to repeat, after 360, the next will be 540. And we can add on another 180, add on another 360. Given that we shall multiply them by 2 and then divide by 5, we can first check with this. X will be equal to 0, that one will stay, because 0 times 2 is 0 divided by 5 stays 0. Then 180 times 2 divided by 5 will give us 72 degrees. 360 times 2 is 720 divided by 5 will give us 144 degrees. 540 times 2 divided by 5 will give us 216. So we can proceed and look for more angles, since this shows us that we are still on course. We look for more angles. The next angle I told you after 540 is 360 plus 0 is 360. 360 plus 180 is 540. 360 plus 360, the next angle will be 720 degrees. Now the 720 degrees is a qualifying angle. We multiply it by 2 and then times 2 and then divide by 5. We'll get 288. 288. We are going to add on another angle here. The next angle will be 900. So 900, we want to see whether it's still in the range. Times 2 divided by 5 will give us 360 degrees sharp. Now we can conclude and say that the values of x that we need, that will be correct for this number, will be 0, 72, 144, 180, which is big from there, 216, 288, and then 360 degrees. These will be the correct values for the solution of our question 17. These will be the correct values of theta for the solution of number 17 of exercise 17H. 0, 72, 144, 180, 216, 288, and 360. After going through those numbers, the other numbers would definitely be proof. We can try out one more, which is 17H, the number 7. It is a proof. They are saying prove that the question states that number 7, that the cos of 3 theta plus the cos of 5 theta plus the cos of 7 theta is equal to the cos of 5 theta into 2 cos of 2 theta plus 1. I already told you that with proofs, we look at sides, and the side that is more complex is the easier side for you to choose to prove. So we shall prove the left-hand side, which is giving us that. When you have a proof of this nature like we saw yesterday, whether it is a solvable proof, you look at any two parts that will give you one of the parts. Remember yesterday we looked at that. If I am to add 5 and 3, can I get 7? If it does not give it to you, then it means that's not the right pair. But again, the answer we expect should give us a hint. This answer clearly tells us that 5 cos of 5 theta is the common factor. And we can get 5 if we arranged 7 and 3 close. So in our attempt to prove this, we can write the cos of 7 theta plus the cos of 3 theta plus the cos of 5 theta. We apply factor formula here. Apply the factor formula to get cos plus cos is 2 cos cos. To the cos of 7 theta plus 3 theta divided by 2 into the cos of 7 theta minus 3 theta divided by 2 plus the cos of 5 theta, which is already there. In our next step here, what we get is 2 the cos of now 5 theta, 10 divided by 2 is 5, times the cos of 7 minus 3 is 4 divided by 2 is 2, then plus the cos of 5 theta. Now the cos of 5 theta becomes common. We pull it out, and here we stay with 2, the cos of 2 theta plus 1, and this is already equivalent to the right hand side, so we can conclude and say hence proved as required. This is enough, hence proved as required. With this narration and guidance, we are going to practice with that exercise and the next exercise for the rest of the lesson today. Have a good day for now. Please practice through to make sure you become perfect. God bless you.